Okay, number 5. It says solve the inequality and graph the result on a number line. 5x plus 7 is greater than 2x plus 1. And just like the previous problem, when we have x's in different locations, we want to get those together first. So let's add negative 2x to each side, or subtract 2x, same thing. And we have 3x plus 7 is greater than 1. Now let's get the constants together by adding negative 7 to each side. We get 3x greater than negative 6. Now we're going to divide each side by 3. Dividing by a positive number such as 3 is okay. It won't change the direction of the inequality sign. And we have just a single x is greater than negative 2. So that's the solution, but we're also going to draw this on the number line. So let me draw this number line. I think on the final exam, the test itself, a number line will be drawn for you. Let's locate negative 2, and this is an open circle at negative 2, and we'll graph to the right. Let's look at number 6. In this case, again, we have two variables, a negative 3x and a negative x, and we have a choice as to which one we want to add to clear. And I think, you know what, I'm going to do it both ways because it's worth looking at. You might decide how you're going to do yours, and I want you to see both options here. Let's see, I'll start by adding x to each side so I can clear the x on the right side and keep it on the left. Let's see what we get when we do that. 4 minus 2x is greater than or equal to 0 minus 6, or negative 6. And now we'll get the constants together by subtracting 4, or adding negative 4 to each side. And that gives us negative 2x is greater than negative 10. Now the key item in this case is the negative 2x. When we see that the x is a negative, then we can multiply each side by negative 1. Right now it says we have negative 2x on the left. We can multiply by negative 1 each side, multiplying the negative 10 also by negative 1. But when we multiply by negative 1, as you know, it's like taking the opposite of something. It has the effect of changing the direction of the inequality. So instead of greater than or equal to, it becomes less than or equal to. And now we can continue to solve. We now have a positive 2x that is less than or equal to positive 10. Dividing each side by 2, x is less than or equal to 5. And let's take a look at the number line graph for that. There's 0. I'll just say that there is 5 right there. And we are going to make this a closed circle. And it graphs to the left. Now I'm going to leave that graph right there and erase what I've done. If you want to pause this, you can and take a look at all the steps, or you can keep going and look at the alternative way, or you can speed ahead maybe if you don't want to know another way. But I'm going to show it anyway on here. So what I want to point out about this is, again, this step right in here, this change where we multiplied by negative 1 each side so that we can make this into a positive 2x. Again, once we did that, we had to make this change in the inequality signs, or inequality sign, from greater than or equal to less than or equal to. Okay, I'm going to erase this and start fresh. Okay, I have a clean slate now. This time I'm going to choose to add positive 3x to each side. As I do, we get 4 is greater than or equal to 2x minus 6. This time we end up with a positive 2x, but it's on the right side. Now I'm going to add 6 to each side, and we get 10 is greater than or equal to 2x. This time we're going to divide each side by 2, and we get 5 is greater than or equal to x. However, we must do one more step, and that step is to write x on the left side. In doing so, 5 will end up on the right, but a change will take place where the greater than will become less than. So it becomes less than or equal to. And you'll notice that's the same answer that we got before, and of course, therefore the same graph.